All right, kiddos, welcome back. Here we are for the second day of remote work. Do check from the first time that we did this. There are lots of us in each class that did not watch the video that I made and posted to YouTube. And when I put it into Google Classroom, I added some questions that you need to answer. It's a very easy assignment, but you do have to go back in and do that. I'm going to do the exact same thing today. Just a very quick review for us about the changes in states of matter. Don't forget, when we have solids, you have the molecules that are very close together. They are tightly packed. And then when we have liquids, you'll notice that the molecules have moved a little bit further apart. And that gives them room to freely move around and bump into each other. And we kind of understand that because we've all dove into a pool before. And then lastly, we have gas, where these molecules have gained a lot of heat energy and are moving around very quickly. And they have even more space in between them than the liquid does. And that's why there's a difference in when we are running across the playground versus trying to maybe run across the pool. Because the molecules are more tightly packed in the liquid than they are in the gas. We did talk about how you change from each state of matter. So when you are a solid and you reach a very particular temperature, so hopefully today the ice that is outside definitely reaches this temperature so that we can come back to school, you will have a melting point. And that is when a solid changes into a liquid. That is the melting point, and you have to add heat in order to do that. Then we have the boiling point. I don't think we're going to get that hot outside today. That is when the liquid becomes gas. And so I think there might be some evaporation outside, but I don't think that everything is going to be gone. I think there will be still some wet grounds and some snow in shady places and things like that. But there might be some evaporation today if the sun is out and is warm enough for certain. But that is when the molecules gain enough heat energy that they move even further apart than they are here, and they turn into a gas. And that is, again, adding heat. And then we have this one, which we got to witness over the last few days. That is when the liquids reach a point that they turn into a solid. That is the freezing point. You have to take heat away in order for that to happen. Then we have condensation. There was definitely lots of cloud formation. I noticed that we haven't been able to see the sun in a little bit. Yesterday was a lot better. But that is when the water vapor rises into the atmosphere and it changes back into a liquid. So we know that condensation is cloud formation from the water cycle. But do remember, you also have to know that condensation means that when water vapor turns back into a liquid, or they might even just put gas into a liquid. And in order to do that, you need to lose heat energy. Here is our state of matter triangle. I kind of have that here as well. We all did that the last time we were together. Again, in order to move from a liquid to a solid, you lose heat. To move from a solid to a liquid through the melting point, you add heat. We have seen this. When you add enough heat to a liquid, you go through evaporation. And with gas, if you take away enough heat, it's going to turn back into a liquid. And we will go over sublimation and desublimation a little bit more when we get back into the classroom. Again, that is our states of matter and how you add heat and gain heat to move from each state. Completely switching gears, although we are still going to be talking about matter, but we're going to talk about how things change. And we're going to define chemical change today. We're also going to define physical change, and we're going to give some examples of those as well. Maybe if this shows up, we're not doing that. I will post this as inside of the Google Classroom assignment so you can watch that. It's a very good video as usual. Study Jams does a great job. Here we go. First definition that I would jot down is a physical change. A physical change in matter does not change what the matter is. It is not a new substance. You'll notice over here we had some green paper that was balled up into a ball. Is it still paper? Yes, it is. If it had changed into something that wasn't paper and it was a new substance, then that would be a chemical change, which we will get to later. But for now, you need to write down that to change matter physically, you do not change what the matter is. There is no new substance formed. So if you need to pause the video, obviously do that. but that is going to be what we put down for a physical change. If you were to cut this paper up very beautifully like this, again, is it still paper? Yes, it is. I know a lot of times you might, hear, and I mean, I'll probably even say it sometimes is a new substance formed, or, can you change it back into its original state is another thing that you might hear people say. Well, it would be extremely hard to change this paper back into what it was originally, a full sheet of paper, but is it still paper? It is still paper. So even if you're cutting the paper like this, it is fine. You can fold the paper. If you want to, you can rip the paper up into shreds. Could you put all that back together after you run it through a shredder? It would be really hard, but is it still paper is the question that you have to ask yourself. Again, you can change the shape or appearance like this, and it's still going to be paper. So this is another example of a physical change. This is where they're going to get us a lot. They're going to talk about the states of water. And I know it does seem like when you change ice into a liquid, or even the converse of that, if you change liquid into ice, it almost seems like you're getting something new. But what I need you to do is think about it on the molecular level. When you change water, those free-flowing molecules, into a solid, those molecules are going to come closer together because that's what happens when you are freezing things, and but it's still water molecules. So again, freezing the water into an ice cube, it's still water. Melting the ice cube into liquid water, still water. And even if you were to boil that water at the end of all that, it's still water. So when we change from solid to liquid to gas in water, it's still the same thing. So it is actually going to be a physical change. Since objects do not become a different substance during the physical change, it's usually easy to reverse that change. So if you were to dissolve sugar or salt into water, you could easily change that. I know you're thinking, but that's a new substance. On the molecular level, it is not a new substance. The water molecules and the sugar molecules don't really mix. The sugar molecules just find a way to make their way into that space in between the liquid molecules. If you were to evaporate the water, if you had either salt water or sugar water, and we'll try to do some of this in class, you're just going to have the crystals left over in the pot, which is something that we might be able to see if we do that. But it is just a physical change when you're mixing some things into water, because you can actually change that back. I'll post this video. I'm not going to watch a video. That's illegal and copyright issues, but I'll post this in our Google assignment for you to watch today as well. Now we're changing. We've talked a lot about physical change. We're going to talk about chemical changes. And chemical changes is a change that causes a new substance to be formed. And you'll notice over here, this is one that they're going to use a lot, and that's burning things. Whether you're lighting a match or you're burning a log, you are turning that into a new substance, and that obviously cannot be undone. You can't take that ash and still use it as paper because it's no longer paper. And you certainly can't take the ash out of the fireplace and burn it again like you would because the wood has changed chemically. So when you have a chemical change, you have a new substance to be formed. The state of matter has turned into a different matter. It's not the same thing anymore. Again, this will be posted for us today. Baking a cake is a great example of a chemical change. You can't go back and get the eggs and sugar and flour and the things that you put into that cake back out. Once you have added enough heat to those different materials, they're going to change on the molecular level into something new. Again, you can't mix all those things together and then taste it. It's not going to taste the same as after you have baked that cake because of the chemical change that it goes through when you add enough heat to it. So baking a cake is a great example of that. Here are some indicators that a chemical change has taken place. It's not true every single time. Of course, they always have these exceptions to the rule, but most of the time. Um, Again, when I say, and here's a great example of how it's not every time. When I say a change of color, certainly if you colored a piece of paper, you've changed the color. It's still paper. Um, but when you have something like if you have metal that rusts and that rust is a different color, the metal was silver, the rust is now this dark brown, burgundy kind of color. That is rust is a chemical change. You cannot change that back. If you have a change in odor, I promise you, if we opened up our decomposition jar, there would most definitely be a change in odor in that. Or if you've ever had milk spoil, there's a change in smell. That is going to be something. Even in the background, when you see these fireworks, that fireworks smell is an indicator that a chemical change has occurred. If you have a change in temperature, whether you are producing heat, exothermic, or you're losing heat, endothermic. I don't think they're going to ask you to know those words, but I'm going to throw them out there for us just to have them in our lexicon anyway. If you gain heat or you lose heat in it, you're going to probably have a chemical change. Now, again, I put ice in water. I'm going to or take the ice out of the water. I'm going to have a change in temperature. Does that mean that I've got a chemical change? No, that is not what that is talking about. Again, we'll be able to go through some of that when we go through chemical changes in the classroom together. But again, if you have a change in temperature, we'll get to see that. You're talking about probably a chemical change. Release of gas. When you open up a soda and you have that release of gas, there are some chemical things going on there. When you mix very particular substances together and they produce bubbles, that is most likely going to be a chemical change that is going on because you're not going to be able to undo that, and there are gases being released. So those are some signs of a chemical change. Now, this can get a little tricky. If you fry an egg, now I know breaking an egg is a physical change because it's still an egg, but when you fry the egg, you have added a lot of heat to it, and you will notice a change in color. Um, and you may even have an odor that comes off of that. But when you fry the egg, it's going to change the proteins in the egg to change, and it cannot be undone. So I know you're saying, but Mr. Bullens, it's still an egg. It is, but it's actually gone through um, a chemical change because it's showing some of those signs of that. And when we know that the proteins in the egg have changed because of the added heat, that can't be undone. And so you now have a chemical change. And they'll throw the frying of an egg on there every once in a while. They'll throw the breaking of an egg on there and trying to trick you. But I think once we talk about that and we look at it a little closer as we get together later on this week, we'll understand that frying the egg is definitely going to be a chemical change. All right, I'm going to leave that there. Obviously, you have some questions to answer after this. I'll leave the Nearpod codes as usual, so you can go back and get any and all definitions that you need. And of course, those videos are attached in there as well, but I'm going to attach them into our Google Classroom assignment. And I look forward to hopefully, fingers crossed, seeing everybody in the classroom tomorrow.